Hello, this is Stephen Whitfield with Drilling Contractor. Right now, I'm joined by Richard Grayson, Senior QHSC Manager and Global Well Control Focal Point at Nabors Industries. And we're going to be talking a little bit about some of the issues surrounding mud gas separators. Mr. Grayson, thank you so much for speaking with me today.
Oh, you're welcome, Stephen. Glad to be here.
So earlier this year at the 2021 IADC Well Control Conference, you participated in a discussion on mud gas separators. Part of that discussion touched on sizing and design issues that can lead to problems during well operations. So I just wanted to ask, could you talk a little bit about some of these sizing and design issues and how do you address them?
Well, so it's possible to size a mud gas separator, and you can run calculations and say that you can put a certain number of a million standard cubic feet per day through one. It should handle that sort of a flow, but really that's only just tangentially important. When you have a well-controlled event that's ongoing, that really doesn't mean much because you never really know exactly what's coming out of the wellbore. And there's no way to do that. You don't know what the exact flow rate is from that well, et cetera. When you look at mud gas separators, well, bigger should be able to handle a little more than smaller ones, but you're never really sure about exactly what's coming out of that wellbore. So you can try and shoot ahead of the bird. That is, you can try and understand what's happening inside using floats or gauges on the top, but float systems are notoriously not very reliable. They tend to have various mechanical problems. We don't even have any of those at my company. If you put a gauge on the top to try to read the pressure that's existing there, there are issues with, well, maybe you're trying to kill the well using an electronic choke and you're in the driller's house and it's on the other side of the rig floor and you can't see it because of the drawworks or wind walls, or the mud gas separator is at the end of the mud pits, and from the rig floor, you just can't read that little gauge, even in the daytime, much less at night or in the rain. So there's a lot of pushback against these sorts of things. I mean, the gold standard would be to instrument the mud gas separator. And if you've got about 3 pressure transducers, one at the top of the, where the vent line, excuse me, exits the top of the vessel, and one at the top and bottom of the return line, you can know what's going on inside that vessel, and you can give that information to the driller and those that are conducting the well kill. But again, that costs money. That's not normally available on a lot of land rigs. You just don't have that sort of instrumentation. So despite all your best efforts, what you're left with in most cases, from what I see in the field, is you're left with the idea that it tells you. So regardless of any sizing, regardless of what the well that you have, you must be sensitive because it tells you. And it does that with what I call blow through. Some people call blow back. You may hear, you're on the location, you may hear someone say on the radio, hey, we've got gas burping at the shakers, and as you're trying to kill the well. And what that's saying is that for some reason, and you may not know what it is, but you've overloaded that mud gas separator and gas is going down that turn line and coming up over by the shakers. And when that happens, you're risking explosion and fire. It has happened in the industry to multiple contractors, and to our regret. And it causes a terrible problem. You're putting your people at personal risk. You are, if that fire, if you've been using oil-based mud, that fire will find its way all over your rig. And you'll most likely have a total constructive loss. So at the end of the day, regardless of any sizing issues, really and truly, it comes down to just paying attention. It doesn't cost a lot to pay attention, and it will tell you if it's overloaded. You simply have to be alert to that and respond by stopping your pump, closing in, and then we need to refill that U-tube. We need to consider if there's anything we can do to remove any restrictions in the vent line that might be there that we didn't know about to start with. And if not, then, we can restart the circulation, but I recommend we slow down to about 1/2 of what we had before. So hopefully those are some answers to what you're asking.
Another point brought up during the discussion at the conference was about the lack of industry standards around maintenance of the mud gas separator, how different companies have inspections of varying scopes. Do you think this is problematic? If so, why do you think this is problematic? And if not, why not?
The way it is the way it is, or why it is the way it is really that most all drilling contractors look to API standard 53 for how to treat their well-controlled equipment, right? That's the document we all look to. And it doesn't really say that much about mud gas separators. It says about three things. One is that you should do an annual check on the wall thickness. And a number to make sure that it hasn't become eroded and it's not thin and brittle and so on. Number two, you need to ensure that it's kept free of debris, but it doesn't really tell you how to do that. And then number three, it says that mud gas separators should be subject to the equipment owner's preventive maintenance system. So all of that is good, but I think in many cases, contractors don't really have a lot in their maintenance system. Like for example, we don't oftentimes tell our rig crews, well, how often should I circulate clean fluid through the mud gas separator to ensure that the mud solids don't settle out, to ensure that cuttings, if we may be conducting managed pressure drilling operations and sending cuttings through the mud gas separator, that they don't settle out and cause a blockage. How often should we open them so that we can check, because it's possible to miscalculate some of our displacement volumes, and it's not supposed to happen, but I've seen them where cement gets inside and sets up. And so do we know that there's no damage inside, or no, how do we know that? And so while it's subject to each equipment owner's preventive maintenance system, I think oftentimes we're just a little lax in determining what we really want to do with that. And I think it comes back to the fact also that these are what we call dumb iron. That means they have no moving parts. How much maintenance can it need? It has no moving parts, but still, and yet it does need maintenance, and it does need to be kept free, and that requires some regular attention.
So training seems to be a big issue. And I guess my question for you on that would be, do you see any opportunities to improve training with mud gas separators? And if so, what would you say those opportunities are?
When you look at the IADC WellShark curriculum, mud gas separators is there. It talks about things like flow rates, blow through, check valves in the vent line. Those are learning objectives that are currently in the IADC WellShark curriculum. So I think, it should be talked about and discussed in all and every supervisor level well control course. However, I do think that what happens again comes back in some cases to the fact that this is dumb iron. And well, there's just not that much to know, right? It has no moving parts. And so I think it often gets overlooked a little bit in favor of instructors spending a little more time on subjects that they deem more complicated, trying to work their students with some additional ideas and learning objectives, when in reality, when we're on location and we're in a well-controlled event and we're killing a well, that mud gas separator is a key piece of equipment, one that has the very real ability to fail us through blow through. And like I said earlier, we're now at risk of explosion and fire. And so it shouldn't be something that's glossed over. Instructors should spend, I think, more time than they generally do talking about do's and don'ts. We have a best practice guide in our well control manual at Nabors, and we talk about that in all of our supervisory level well control training courses. And so it's there, but I think it sometimes just gets glossed over a bit, and I don't think that's good.
Well, Mr. Grayson, thank you again for taking the time to speak with us today. Mud gas separators are such a critical part of well operations, and maintaining them, operating them, that is equally critical. So thank you again for taking the time to speak with us.
Oh, you're very welcome anytime.
And thank you for visiting Drilling Contractor.